Okay, in this video we're going to look at solving quadratic equations. Now solving quadratic equations is really just like finding the x-intercepts for a parabola, but now we're just not graphing. Okay, so we're doing a little bit less work. So a quadratic equation, again, is anything that has an x squared. So let's say we have the example x squared plus 12x minus 28. Okay, and this equals 0. Okay, so again, it's just like finding the x-intercepts. We want to know, when is this bungee jumper on the bridge? That's what solving quadratic equations are. When is the bungee jumper on the bridge, or where is the water balloon on the ground? Okay, we want to find where he jumps off, where he comes back up. So we do it the same way. Okay, we need to use the zero product property. So we need to use the zero product property, which means we must factor. Okay, so we're good at factoring, so let's factor this. Generic rectangle, diamond problem, this is automatic at this point. X squared in the bottom left, units in the upper right. Multiply, negative 28x squared on top. Remember, the cross products have to be the same, so that goes on top. And these two are the x's, and they have to combine to 12x. Okay, two numbers that multiply to negative 28x squared add to positive 12x. Again, we need one of each. So I'm going to have a positive 14x and a negative 2x. 14x in the upper left, negative 2x in the bottom right. Again, I factor quickly because we should all be factoring quickly at this point because we've been doing it for so long. So, fill in the numbers on the outside. X times x is x squared. X times 14 is 14x. X times negative 2 is negative 2x. So now we have our factors. Okay, so we have x minus 2 times x plus 14 equals 0. So our zero product property says, since we have a product that equals 0, okay, if we have two numbers that equal 0, we know either one of those numbers has to be 0. That's just common sense. So our first number is x minus 2, so we want x minus 2 to equal 0. So what number minus 2 equals 0? Well, that's x equals 2. Okay, 2 minus 2 is 0, or we just add 2 to both sides like we're solving an equation. That's really all we're doing. X plus 14 equals 0. Subtract 14 from both sides and get x equals negative 14. Okay, that makes sense. When x equals 2, 2 minus 2 is 0, so we're doing 0 times something. It doesn't matter what this is, but 0 times anything is 0. When x equals negative 14, okay, this is actually negative 16, but negative 16 times this 0 is still 0. And that's it. Okay, before these would be our x-intercepts and we plot them, but we don't care about graphing this parabola. Okay, these are the two answers. He jumps off the bridge at negative 14. He comes back on the bridge at x equals 2. That's all we care about. Okay, next example. X squared plus 5x plus 12 equals 6. Okay, now this one's a little bit different. Okay, and we want to notice what's different about this one. Well, this one doesn't equal 0. Okay, now when this is the case, okay, we can't factor and set them both equal to 6, okay, because we don't have a 6 product property. We need a 0 product property. We want to know, when is this bungee jumper on the bridge? Not when he's 6 feet above the bridge. We want to know, when is he on the bridge? So we need it to equal 0 because we want to know when is he on the bridge. So again, let's not get afraid. This isn't a complicated step. We've been solving equations since the beginning of the year, so we know what we're allowed to do. Okay, we have 12 units on the left, we have 6 units on the right. I want to get all these away and be left with nothing, so I'm going to subtract 6 from both sides. Okay, our rules for equations don't change even if we have an x squared on it. We still could add to both sides, we could still subtract to both sides, but we need it to equal 0 because we want to know, when is this bungee jumper on the bridge. So x squared plus 5x, I'm taking 6 units away from the left, so I'm left with 6. Because I take 6 away from 12 and I'm left with 6. And I take all 6 of these away and I'm left with nothing. Okay, now I'm happy. Okay, because now it equals 0. So now we could factor and use our zero product property. Generic rectangle, diamond problem. X squared on the bottom left, 6 in the upper right. These two multiply to 6x squared. So these two have to add up to 5x. Okay, two numbers that multiply to 6 add to 5. That's 3 and 2. So we have 3x and 2x. Fill these in. And you should be doing it this quickly as well. Okay, because we've been doing these for so long. So we have x plus 2 times x plus 3 equals 0. So zero product property. X plus 2 equals 0. X plus 3 equals 0. Both of these factors have to equal 0. Subtract 2 from both sides, x equals negative 2. Subtract 3 from both sides, x equals negative 3. He jumps off the bridge at negative 3. He gets back on the bridge at negative 2. That's what we want to figure out. Okay, great. Okay, so solving quadratic equations, again, we're just looking for the x-intercepts. Where does he jump off the bridge? Where does he get back on the bridge? Or where do we launch the water balloon and where does it land? That's what solving quadratic equations always asks. Okay, so we're going to have two answers for now most of the time. Sometimes we might have one, sometimes we might have none, but for now we should be getting two. Okay, so try a couple examples on your own. Here's the first one. Here's the second one. Here's the third one. And here's the last one. Sorry, these equal 0. Okay, so press pause, give these a shot, then press play when you're ready to check your work. Okay, this first example, I hope you weren't scared of it because this was actually easier than all the other ones. Okay, I already factored it for you. Okay, this is already factored. So we're just going to jump right to the zero product property. Okay, there's no sense multiplying these together and factoring them again because you're just going to get x minus 7 times x plus 11. When it's already factored for you and we notice the product equals 0, we're just good to go. So we want x minus 7 to equal 0, which means x equals 7, or x plus 11 to equal 0, which means x equals negative 11. Jumps off the bridge at negative 11, gets back on the bridge at x equals 7. Okay, so that one's really easy. Okay, now let's look at the second one. Okay, we have to do a little bit more work. So we have to factor this. 2x squared in the bottom left, negative 3 in the upper right. Diamond problem, they multiply to negative 6x squared. Add to negative 5x. Okay, that's negative 6x and positive 1x. So you have 2x and x. This is 1 and this is negative 3. So you have x minus 3 times 2x plus 1. This equals 0. Okay, this one's easy. So x minus 3 equals 0. So that means x equals 3. Now this one, I hope you weren't confused here because we're doing the same thing. We want to know when will 2x plus 1 equal 0. Okay, just because all the other examples were whole numbers doesn't mean we're never going to get to an example that has a fraction as our answer. We want to know 2 times what number plus 1 equals 0. So we go back to solving an equation. If we think back in the beginning of the year, if I just gave you this equation, it'd be easy to solve. So we don't want to get scared of it just because it's in a harder context of a problem. So we subtract 1 from both sides because to get rid of this plus 1, so we subtract 1 or add negative 1 to both sides. So we get 2x equals negative 1. Now we divide by 2. So x equals negative 1/2. Again, when we're just doing negative 1 divided by 2, we leave that as a fraction, negative 1/2. We leave things as fractions because we don't need calculators for it. Okay, so these are the answers. Jumps off the bridge at negative 1/2, gets back on the bridge at x equals 3. Okay, we aren't afraid of this fraction. All we do is we just do it the same way. We set this factor equal to 0, and we solve it like we've been solving equations since the beginning of the year. Add -1 to both sides, so we have 2x equals -1. Divide by 2, and we get x equals -1/2. Okay, this example, okay, we're equal to 0, so we're good to go. So let's factor this. So we have the negative x squared in the bottom left, -12 in the upper right. Negative x squared times -12 is positive 12x squared. These have to add to -7x, so this is -4x, and this is -3x. So we fill these in, -4x, -3x. Okay, two numbers that multiply to -x squared, so we have -x times a positive x. We need one of each to get our sign negative. Now be careful with your signs here. -x times 3 is -3x, and x times -4 is -4x. We can just check that we get -12 by multiplying 3 times -4, which we do. Okay, so whenever you have a bunch of negatives in your generic rectangle, make sure you're very careful with how they are on the outside. So our two factors are -x minus 4 times x plus 3 equals 0. So we have -x minus 4 equals 0. Again, we just got to solve this like we know how to solve. I'm going to add 4 to both sides, so I get -x equals 4. So if -x equals 4, that means x equals -4. Okay, that makes sense. The opposite of -4 is 4, minus 4 is 0. And this one's a little bit easier. X plus 3 equals 0, which means x equals -3. Okay, this water balloon is launched when x equals -4. It lands when x equals -3. Okay, in this last example, again, we can't factor right away because it doesn't equal 0. Okay, we need to figure out when is this bungee jumper on the bridge or where is this water balloon on the ground. So we don't want it to equal -9. We want it to equal 0, so we have to add 9 to both sides first. So we have x squared minus 6x plus 9. Again, we're adding 9 units so they don't combine with any of our x's. And that equals 0. That's how we get rid of this -9. So we add 9, and we're just adding the 9 units on at the end because they don't combine with our x's or with our x squared. Okay, now we're equal to 0, so now we're ready to factor. Generic rectangle, x squared bottom left, 9 in the upper right. Two numbers that multiply together to get 9x squared, add to -6x. This is -3x and -3x. So here we have x minus 3 and x minus 3. So this is x minus 3 times x minus 3 equals 0. And we notice we have the same factor. So this means x equals 3 for this one, x equals 3 for this one. And this is one of those times we're only going to have one answer. Okay, so x equals 3 is our only answer because we see that it repeats. Okay, so if you need more practice with this still, refer to the textbook or some of the other online resources.